Hey guys, we're going to go ahead and move on to a Unit 7 review. This was all about rational functions. Remember, rational means that we can express it as a fraction. So we're going to have these functions, these expressions in terms of fractions. So let's go ahead and go over some of the types of problems that you might see in rational functions. So maybe I would want to simplify, a rational function that looks like this. So we've got two trinomials, one in the numerator, one in the denominator, and we want to simplify that. So to do that, we need to factor out or factor both the top and bottom. So the first thing I'm going to look at is the numerator. Can I take anything out? Is there any greatest common factor? In this case, no, there's not. Is this the difference of two perfect squares? Well, remember, difference would be subtraction, and you would only have two terms. So, no, it's not the difference of two perfect squares. So now I'm going to go ahead and factor this as a trinomial. So I'm going to take the 21 here, and I need to come up with numbers that multiply to 21 and add to 10. And this has to be a positive 21 and a positive 10. So then I'm going to go ahead and list my factors of 21. Well, I have 1 and 21 and 3 and 7. So now I'm going to look at my pairs here. Well, 3 and 7 are the ones that could add up to 10. 3 plus 7 is 10. 3 times 7 is 21. So I'm going to take these numbers here and write x plus 3 and x plus 7. Then I'm going to look at the denominator. Again, there's no greatest common factor. It's not the difference of two squares. So I'm going to factor it as a trinomial. I'm going to take 7 here. I have to multiply to get there. And 8 I have to add. Well, this one's pretty easy. The only factors of 7 are 1 and 7. And 1 plus 7 does equal 8. 1 plus 7 is 8. And 1 times 7 is 7. So again, I'm going to take these two numbers here and go x plus 1 and x plus 7. Now I'm going to look, can I cancel anything out? Well, I have x plus 7 on both, so my final answer would just be x plus 3 over x plus 1. All right, let's go ahead and talk about adding and subtracting. So if I had something like this, 3 over x plus 1 minus 5 over x minus 4, let's say. So we went through a whole series on how we had to add and subtract our rational functions, and then we came up with kind of a shortcut, if you remember, in class. So first of all, our denominator would be just taking these two denominators and multiplying them. Now we don't need to actually multiply them out. You can just write them like this. Then what we would have to do is kind of like cross multiplication. What's important here though is that this is a subtraction that we're subtracting here. So what we're going to do is we're going to take this subtraction and move that negative sign here and change that to a positive. So we're taking that negative and moving here. Now we're going to go ahead and cross multiply. 3 times x is 3x. 3 times negative 4 is negative 12. Then we're going to go the other way. Negative 5 times x is negative 5x. And negative 5 times 1 is negative 5. Now all I have to do is combine my like terms. I keep my denominator the same, and I'm going to combine the 3x minus 5x to get negative 2x. and negative 12 minus 5 is negative 17. We also talked about excluded values. So if I had a function like this, and I wanted to know what the excluded values are. Okay, the excluded values make the denominator 0. It doesn't matter about the numerator. We can have 0 in the numerator all we want, but we cannot have 0 in the denominator. You cannot divide by 0. So to find the excluded values, we're going to take the denominator and set both of those equal to 0. So we take the x minus 7 equals 0, x plus 6 equals 0. Then we're just going to solve. So I'm going to add 7 to both sides here, so I get x equals 7. And then subtract 6 here to get x equals negative 6. Okay, next type of problem is going to be very similar to what we saw in the first problem. So let's say we have something like, we want to simplify and let's say we have x plus 4 here. And then at the numerator, we're going to have x squared plus 4x minus 5. And then we're multiplying. So before you would start like multiplying across or anything like that, let's see if we can simplify what we have by factoring. So none of these can be factored because they're just binomials. We can't take anything out. It's not a trinomial, not difference of two squares. But we can factor this here. So again, I'm going to take a look. I need to multiply to negative 5 and add to 4. So if I look at my factors of 5, well, that's just 1 and 5. And if I want to add to positive 4, I would have a positive 5 and a negative 1. So 5 minus 1 is 4, so that works. 5 times negative 1 is negative 5, so that works. So this could be rewritten as x minus 1 times x plus 5 over x plus 4 times x plus 4 over x minus 1. So again, I just rewrote everything else. All I did was take this trinomial and factor it into here. Now we can go ahead and cancel. We have x plus 4, that goes away. The x plus 1's go away, and we're just left with x plus 5. Okay, we have 2 more problems to go through. The first problem talks about key features. So if I have f of x equals 2 over x plus 1 minus 4, let's say. All right, so we want to know what the vertical asymptote is. So your vertical asymptote is always going to be whatever this, what I'm going to call a tail. I don't think that that is the, the official word for that, but it's kind of hanging off the side of your function. So my vertical asymptote is going to be, excuse me, I messed that up. Sorry about that. That's your horizontal asymptote. Sorry about that. So it's still your tail. It's y equals negative 4. So your horizontal asymptote is, and I think about this and how I knew this was wrong is because my horizontal asymptote has to hit the y-axis, so it has to be y equals. Okay, now my vertical asymptote. Your vertical asymptote is set your denominator equal to 0. So if I have my denominator here at x plus 1, I would just say x plus 1 equals 0. Subtract 1 on both sides, So x equals -1. Okay, next one would be your x-intercept. So your x-intercept is where your y value equals 0. So remember that f of x and y are the same thing. So I would have to take where I have the f of x here, I'm going to replace that with 0 and say equals 2 over x plus 1 minus 4. So I set that equal to 0 here, and now I'm just going to solve for x. So the first thing I'm going to do is add 4 to both sides. So now I have 4 equals 2 over x plus 1. And then to get rid of the x plus 1, I'm going to multiply x plus 1 on both sides. So what that does is it gets rid of my fraction here. So now I have 4x plus 4, because I'm multiplying that 4 to each of these, equals 2. And then I just solve. Subtract 4 on both sides, so you get 4x equals -2. And then divide by 4, x equals -2 over 4, or x equals 1/2. I'm sorry if you didn't see that, so let me make sure that we go through that one more time. So again, I added 4 on both sides. Then I multiplied by the denominator to clear that denominator out. But what you do to one side, you have to do to the other. And then I distributed that 4 to get 4 times x is 4x, 4 times 1 is 4, and then just solved the equation. Okay, the last thing that we have to find there would be the x-intercept. And that's where you plug, oh, I'm sorry. Did I just do that wrong? Oh, I just did the x-intercept. Sorry, guys. I have to find the y-intercept. And you do plug 0 in for y, or for x. Plug 0 for x. So here's my original equation again. F of x equals 2 over x plus 1 minus 4. Let me just double check that. Make sure I have the same one. Yep. And now if I want the y-intercept, I'm going to plug in 0 for x. So I'm just going to go 2 over 0 plus 1 minus 4. Well, 0 plus 1 is just 1, so now I have 2 over 1 minus 4. And 2 over 1 is just 2, so 2 minus 4 is -2. All right, our very last type of problem is an equation where we have to solve for x. So this one is kind of a long one, but just stay with me and then we'll be all done. So if let's say I have x over x plus 3 plus 4 over x minus 2 equals x squared over x squared plus x minus 6. Now, what I have to do here is I have to solve for x. So I want to look to see if there are any patterns. And the first thing I'm going to notice is that 3 minus 2 is 1, and 3 times -2 is -6. So this is actually a common denominator of these two. So now what I need to do is get these to have the same common denominator. So I'm going to rewrite this. And I'm going to factor this one out to be these two. Okay, so all I did was trying to get the common denominator here, which is this. So this x squared doesn't change. And just like we did in the previous problem, even though that was subtraction, we're going to go ahead and kind of do that cross multiplication thing. So I'm going to cross here and say x times x is x squared, and x times -2 is -2x. Then I'm going to cross here. 4 times x is 4x, and 4 times 3 is 12. What's important to see here is, though, once we have the same denominator, we don't even really care about that denominator anymore. Now it's all about the numerator. So let's go ahead and combine our like terms. We have x squared. Negative 2 plus 4x is positive 2x plus 12 equals x squared. Now I'm going to go ahead and subtract x squared off from both sides. And what I end up with is 2x plus 12 equals 0. I want to get x by itself, so I'm going to subtract 12 from both sides. So 2x equals negative 12. And then divide by 2, x equals negative 6. And that's it. All right, again, hop on a Zoom call if you have questions, send an email. Thanks, everybody.